Hello again. Today's lesson in our Information Technology series on the Practical Assessment Task, or PAT, deals with IPO tables. So far we've covered Phase 1, Research and Analysis, and we've already moved on to Phase 2, Design the Solution, where we learned about program specifications and algorithms. We now move on to the first lesson on IPO tables, in which we'll learn about drawing up input, processing, and output tables. Everything you do in Phase 2 will go into your design document, so keep good records. By the end of this lesson, you should be able to draw up an IPO table for a given event to include input, processing, and output. Tabo's already here, eager to carry on with his PAT.
Definitely. I've created algorithms for each event in my practical assessment task, like you showed me the last time.
Good. Today we're taking it a step further. We're going to use these algorithms to create IPO tables.
IPO as in input, processing, output.
That's it. An input, processing, output, or IPO table is intended to show the input, processing, including storage, and output that will occur in a particular event. Take a look at the following graphic user interface, or GUI, and tell me what we're dealing with: input, output, or processing?
Definitely input.
And how does the user give input in this case?
By using the keyboard or mouse and selecting something.
Yes, the user interacts with the input components on the screen. These input components are input boxes. The user must use the keyboard to type in the input. When the mouse must be used, there are radio buttons, check boxes, and combo boxes. Selecting a button by clicking on it is also input. So we can see that some of the input during an event is given by the user. The user can use the keyboard or mouse or interact with the input components provided on the graphic user interface, or GUI. Take a look at this GUI. What are the output components in this case?
Text panes to show large amounts of information, and labels to show small amounts of information, and message dialogues to draw users' attention to something very briefly during the event.
Very good. What about processing?
That is when data is compared, calculated, or changed in some way, or when data is moved between temporary and permanent storage.
The processing column in an IPO table shows the algorithm for processing and storage during the event. Let's try to create an IPO table for a register event. Remember how a register event works?
The user provides some input and the program stores the input in the database.
That's it in a nutshell. Let's use this example.
Ah, Tabo Mobile, that's me.
What input would you provide?
Input. I'll select a grade from the combo box. I'll type in my first name and surname, and my password twice. Strange how it comes up as XXXXX.
That's just a character hiding each letter of the password. It's one of the properties you can set for a text box. You can choose what character you want, dots or stars, for example. It's important to remember that the actual password is input and stored, not the XXX hiding the password. What do you do once you've provided the information the GUI asks for?
I click the OK button.
Let's look at our example again. This one is called Submit Application for Registration. It has the same effect as an OK button, but it gives the user a bit more information. What will happen in the program when you click on this button?
It will trigger the event to start.
What will happen next?
You get output, a welcome message that tells me my username.
What happened to the input Tabo gave before the output was seen? I'm sure you realized it was stored in the RAM until it was processed. In this case, the password length was checked and the username had to be created. The program checked that the username had not already been given to someone else. Then,
it was saved permanently and bam, output.
The program takes the input from the components, stores it in temporary memory, the RAM, processes it, sometimes using other available data, and saves it in permanent storage, the files on the hard drive. Then the program gives feedback or output to the user, like in the example we used earlier. And here, the output informed the user of his username, but if the password was not long enough, there would have been different output. A message telling the user what the error was and how to correct it. IPO tables are used to show all this input, output, processing, and storage for an event. So IPO tables reflect what is happening in the program behind the GUI or screen. Let's look at the IPO table for a register event. This user is going to register on the system and then his details will be stored in a database. This register event inputs the user's details to be stored as a new record in the database. Take note that the grades are shown in the IPO table as available. This means the program has access to additional data which does not have to be input by the user. All three grades are available and the user gives input by selecting one grade. Available means all data needed by the event that will not be input by the user. Available can refer to local or non-local values and the data in files, including values stored in constants, for example, the fixed price of an item. Values stored in non-local variables or arrays by the processing which occurred in another event, for example, program start or open event. The data in the fields or attributes of an object in RAM, which can only be accessed by calling the methods of that object. The data in files like databases and text files stored on the hard drive. The values stored in local variables are not mentioned because those are the variables you will use for input, output, and processing during the event. They will be shown in the appropriate column of the IPO table. Ready to compile an IPO table for an event?
Sure.
The easiest way to create an IPO table is to use the algorithm you wrote and saved in an MS Word document. Just open your algorithm file and save it as IPO tables.
Do I need to do an IPO table for every algorithm?
Yes, and it's important to give each table a heading and summarize what's happening in the event. You gave your algorithm's heading, like for example, register event. To name your IPO table, use the different event headings and add the words IPO table for in front of them. Here's one. IPO table for register event. Once you have a heading, insert a comment just under it to summarize what's happening in this event. The IPO table for register event inputs the user's details to be stored as a new record in the database. Remember, this must be a summary. When you write your program in phase 3, you can copy and paste this comment as part of the internal documentation for your program. Now you're ready to insert a table. How many columns would you need?
I'd say 3. One for input, one for processing, and one for output.
Spot on. Our IPO table will look something like this. It should have a heading, a comment that summarizes what it's about, 3 columns named input, processing, and output. And because this is a copy of your algorithm document, the algorithm will be just under this table. Cut and paste it into the processing column, like this. Even if you don't have an algorithm, you still need to complete this column first. Now the rest is easy. Read each of the steps in the processing column carefully. See what data is needed. Decide whether it must be input by the user or whether it must be available to the event. Now fill in the input column. Firstly, we input the grade. Selected grade means that we must store the selected grade in a variable named grade. We must also store the first name, surname, and the password. Then add the available data items. The grades must be available for the user to select from. You should mention the GUI component, the combo box, so that it is clear where the data will come from. Here it says we must fetch stored usernames from the learners table, so the usernames must also be available. Complete the output column. Notice that the user must not see all the usernames, so we don't add that to the output column. And show what the user must see after the processing has been done. Display message. Notice that there is a variable named new user that will be used during processing. When you write your program, look for variables like these and the variables mentioned in the input and output columns. It is very easy to see which variables must be declared as local variables. Grade, first name, surname, password, new user, and username.
Do I have to refer to the input and output components, like a text box or devices, like a mouse or printer that will be used?
No, but you must refer to components, objects, variables, constants, arrays, and files that store available data. Look at the available section in our example. The available section is used to see which non-local variables you need. These are variables that will be used by other events in your program. You may find that you need to alter the algorithms you wrote and saved in the algorithms file as you create the Ipo tables. Sometimes because you made a mistake, other times because you find a better way to do things, or identify something you have left out. Remember to go back to the algorithms file and change the algorithms there as well.
I'm a bit confused about available data and the local and non-local variables. Could you show us another example?
Sure. Let's say your school's dramatic society is presenting a musical. What are the ticket prices?
R5 for children, R10.50 for adults. And how about R7.50 for pensioners?
The GUI that will be used to calculate the cost of tickets might look something like this. There are two button-click program events. Can you identify them?
Add tickets and calculate the final total.
Remember that clicking the button triggers an event.
Oh, yes. So we have the add tickets event and the calculate final total event.
Yes. The add tickets event calculates the cost for the given number of tickets for an age group. And let's assume each age group is selected just once. A number of tickets are selected, and the total for that group is calculated. Let's also assume there's no screen output when the Add Tickets button is clicked, and the Calculate Final Total event that prints a thank you, including the name, prints any subtotals, then prints the total cost in currency format. Can you tell me what must be available for the add event to function? Now remember, available is a list of all data needed by the event that will not be input by the user, but might be selected by the user. Look at the GUI again. Let's start with the radio buttons.
The age groups child, adult, and pensioner are available.
Correct. What else?
We can't see it here, but the price of one ticket for each age group.
Good. Break it down for me.
child price, 5 Rand 50, adult price, 10 Rand 50, and pensioner price, 7 Rand 50.
That's right. Where will the prices be stored?
In a text file?
A text file is a possibility, but there are only 3 values to store, so 3 non-local constants would be a better option. The constants must be non-local because they are also needed by the calculate event. All of these will have to be listed under available. And although you don't have to mention it now, there will have to be non-local variables to store the data from this event, which must be available for the calculate event. 3 variables to store the number of tickets and 3 variables to store the cost of tickets for each age group. What input is needed for the add tickets event?
The user must input the number of tickets and select an age group.
What about the user's name?
That is only needed in the calculate event.
Yes. If we input it during this event, we will have to store it in a non-local variable, so it can be available for the calculate event. But we don't need it for this event, so we should rather do the input where it is needed. Now, can you tell me what must be available for the calculate event?
The number of tickets bought for each age group, the price of 1 ticket for each age group, and the cost of all tickets for each age group.
If we displayed a different message, such as the name of the show they'll be watching and a line of text each time tickets were added in the add tickets event, we would only need to have the cost of all tickets for each age group available, so that the total could be calculated. We could then display a thank you just after we display the total price. That would actually be a better way to code these 2 events. But let's stick to our example. What input is needed for the calculate event?
Only the name, because all the other data has been calculated or input in the add tickets event and is available.
Very good, Thabo. You shouldn't make final decisions about all the components to use on your GUI at this stage. The GUI is the last thing to be designed in phase 2, but it's helpful to have an idea of which components could be used to show available data that the user must select from. If we list what is available in a separate row at the top of the processing column, it is much easier to see which data storage components must be on your GUI before you add any components for your user input. You can also see which data files the GUI must use. This can help you write classes for new objects in your program. Like in this register event. First, you need to place components to hold data. When you are designing the screen for the register event, you can clearly see that you need a combo box and that this screen must use your database. You can also see that the user will not be shown the contents of the database. Then you can use the input and output columns to decide which components to place for the user's interaction with the program. Once you've created your Ipo table, stated what is available, and completed your input, processing, and output columns, you need to look more closely at the data you will be storing, either temporarily or permanently. We'll do this in the next lesson. For now though, here's today's task. Your teacher needs a program to allow her to record marks quickly and accurately. The exam is worth 75 points. She will enter an exam mark and needs to know the letter grade, A+, A, B, C, etc. for that exam. Draw up an Ipo table to show the solution to this teacher's problem.